Hi guys, this is to know about the Bezier curves program. So this is the function used to generate the Bezier points like how we have seen in the previous video. And here we are making use of a blending function JNI of t, which is having this form that we have already seen in the previous video. And here for the given number of points, it's going to create or develop the number of Bezier points required. So it's going to call for how many control points are there, and depending upon that generate the Bezier curve. This function is applicable for any number of vertices, that is control points. So in our program we are going to make use of 4 control points since we want a wavy structure for the flag, and which has been taken in the previous video with fixed number, that is 4 fixed point. We can make use of a wavy form for flag. In this case, one thing you have to know, we are not just creating a wavy form, but we are going to show like the flag is fluttering, right? So in order to have that, we have to make changes with the orientation of the points, whereas during the wavy form this first point is fixed. So whatever you have the point fixed to the stick of the that is the flag, it's fixed first point, and remaining points will be changing. If you see the output of the program, you'll get to know how the first point is fixed. So in this program we are going to go for generation of the menu having 3 options: to animate, to stop animation, and exit. And again in the display function I have set it for calling for wave of 1 if choice is equal to 1, otherwise wave is equal to 2. So in this case, wave is equal to 1 means it's going to extract the updated value of the wave and it's going to project. In turn, we'll be feeling like it is actually animated. If it is not, then it is not going to extract. So that's what happens in this function. The function is the wave function. In this one, we have set the number of control points to be equal to 4. That is a cubical Bezier point, and here number of curve points are 20. So for the curve we are going to consider 20 points, and these are the 4 points, control points taken for the flag. So 20, 100 is the fixed point. This is the point fixed to the stick. The remaining one is helping us to show the waveform of the flag. So for this case, we are going to recreate the values required for the remaining 3 points. First point is fixed, and second, third points will be getting updated values with respect to their orientation towards the first point. This is the formula that I have extracted online for generating a wavy form for the flag. And in this case, we will be incrementing the value of theta by 0.5. So here what happens, it is going to continuously run. Due to the main loop, it's going to continuously run. And what happens is, since the choice is 1, it's going to continuously update the angle also. And hence it is going to change the orientation of the second, third point with respect to the first point. So in turn, the Bezier curve is changing its location, but we don't feel like it's changing its location. We feel like actually it is a fluttering flag. But here in this case, since control points are moving, in turn the generated Bezier curves will be changing its shape, okay, or nature, you can tell. In this case, we are going to set the point size and the line width, and then again call for the field line. So here we are going to generate the points, right? So in this case, from 0 to 8, okay, we are going to have 0 to 7, that is 8 iterations to generate Bezier points with the difference minus 0.8. So it's going to decrement the y value, means the beginning of yellow color till the end of the yellow color we have total 8 iteration with the difference minus 0.8 along the y axis for generating the yellow color. Same logic, set the color, once again call the same logic for 8 times with minus 0.8 difference. So along these y-axis lines or paths, we will be having Bezier points generated. So think that the flag is generated. Now the GL lines will help us to draw the stick. Stick is just a line with the line width equal to 5. We are going to generate the lines from 20, 100. If you see, the 20, 100 is the first point of the flag, fixed point of the flag, and that is the beginning part of the stick. And second is 20, 40, which is the below part of the stick of the flag. And in this case, m equal to 1. If we call for post redisplay, updated value will be extracted and stored in the buffer, and it will be projected towards the screen. So if m equal to 1 means we are animating the flag, post display will be called and it's going to access and show the updated value on the projection. In turn, we feel like the flag is animated. If it is not, if the condition fails, it's only going to call for glut swap buffer. Since post display was not used, the updated value is not present in the buffer. So in turn, what happens, it's going to just show the static image. So whatever was there, that only will be remaining in the display. So above function, if you see, it is a function designed for menu, and for in case that is choice is equal to 3, it is going to exit the program. Otherwise, these 1 and 2 cases are actually dealt by our wave function itself. It's when we call for display, as soon as display is called, it's going to keep track of the mouse input and it's automatically going to call for the animation of the flag. Then you have the Bezier point generation. In this case, we are going to update the values for the Bezier curves. So for Bezier curves, total number of Bezier points are 20. So that is the limit we have considered here. The line strip is drawn, and here the first part of the formula binomial function is generated, and then again it's going to call for the other remaining part of the Bezier points. So in this case, a parameter u is computed, that is k divided by a number of points. What is k? The current point. That is current value of k divided by number of points is nothing but 20. So 1 by 20, 0 by 20, 1 by 20, 2 by 20, like that you will be getting its value, and compute Bezier point is going to get that point generated u value and address of the Bezier curve point. So what is the value to be generated over the curve path? Then again, how many control points are there? Then again, what are the control points? And then again, the C is the one which is holding the required value with the binomial function. So that binomial function is actually called upon here. That factorial representation formula is there, right? That will be actually calculated by binom function here. And the compute Bezier point is the function which actually generates the point required for the Bezier. So as we are going through this particular function, in this u will be passed as an input. That u will be taken as input by the compute Bezier point and hence will be operated. This u is nothing but, I'll show you in the formula, that is n minus, that is sorry, n comma I will be taken, and that is nothing but our function, that is power of uk and power of 1 minus uk minus 1. Here it is there, t of I, t to the power I and 1 minus t to the power I. These values are actually going to be evaluated by the u value. So in this case, power of k represents the first term and power of n minus k represents the second term. That was a generalized formula for Bezier point. Now we are applying specifically for just 4 points, and that will be considered as the formula for the current flag point. So power of u comma k and power of 1 minus u comma n minus k will be taken. So once the blending function is calculated, what is the blending function? I told you, right? This part, second part. So where is it? The formula here. This is the blending function. So this is what is computed now using that formula. U to the power of k means t to the power of k. 1 minus t of n minus I means it is the second one, that is I minus t means there 1 minus u to the power of that is minus function that they have taken. So in this case, to the power of n minus k have been taken. N is number of points. So using that value, we will be calculating the Bezier points x, y, z. X, y, z plus means for the existing value, whatever it may be, you are going to add with this difference. That is current points x value, that is control points x value multiplied by the blending function value. This is the one which actually generates the required points. So you have seen in the video, along L0 we are going to get L0 and L1 we are going to get Q0 and Q1 values, right? So in this case, between P0 and P1 we'll be getting L0 values ranging from t equal to 0 to 1. In the same way here also, for every control point that we have considered, it's going to calculate so many values ranging from 0 to 1. It's going to take the value of t, that is u in this case, and for that one it's going to add the required or the previous value existing, and then again it's going to obtain the Bezier point with the help of the blending function and display it on the display. So whatever color distribution you have seen as a flag, it's all the number of Bezier points generated using this function. So here all these together will be contributing towards generating the flag. So in case you have any doubt with respect to any statement, you can text me or call me. I'll rectify the doubts.